Hello everyone and welcome to the introductory lecture, Introduction to Systematic Reviews, to kick off the Systematic Reviews and Critical Appraisal module. So today I'm going to be giving you an overview of systematic reviews. I'm going to identify what a systematic review is. I'm going to tell you a little bit about the history and origins of systematic reviews, why they're important, how you would be able to identify a systematic review, and what are the stages of a systematic review. And later on in the course, you'll be looking at a systematic review using a quality assessment tool. So what is a systematic review? Well, the important part of this definition is that reference to limiting bias. Now, when we select studies to support an argument, we can be guilty of only picking those that support our argument. We may ignore important variations that don't fit the particular pattern that we're trying to get across. So according to this authoritative dictionary of epidemiology, a systematic review involves strategies that limit bias. And you'll notice that this occurs at several stages in the review process. We want to limit bias when we assemble the studies together. We want to limit bias when we look at the quality of those studies, and we want to limit bias when we synthesize and present the results of the relevant studies. And if you think about how reviews have been produced in the past, the so-called narrative reviews, perhaps that you would see in the pages of an authoritative journal like the Lancet, then we can see some of the limitations in terms of bias. Here we have a pretend version of a recipe. This is how people very often produced reviews, that they would take a simmering topic, a topic of interest, they would extract the juice of an argument, they would add the essence of a filing cabinet, so articles that they have come across, they would sprinkle it liberally with their own publications, and they would sift out the work of people who disagreed with them. And of course, we can see the potential for bias at each of these stages. Another definition that you'll find helpful appeals to the economy and efficiency of using systematic reviews. If you can try and imagine yourself with 20 articles on the same subject on your lap, trying to juggle these, make sense of them, spot patterns between them, well, a systematic review can be seen as a very efficient way of looking at those same 20 studies in a structured way, so that you can summarize them, so that you can appraise them, and so you can communicate their results. And so it's a very practical way of managing quantities of research. This definition from the Cochrane glossary, produced by the Cochrane collaboration, picks up on some of the features that we'll be exploring later. A review that is systematic has a clearly formulated question, so clear components about what will be included and excluded. It has clear methods of identification, the searching, of selection, choosing the relevant studies, and quality assessment or critical appraisal, and also in the methods of collecting and analyzing the data. Now, an important point here is that a systematic review does not necessarily involve a meta-analysis. It will only include a meta-analysis if the results allow you to do this. So a systematic review is, if you like, an umbrella term, and a subcategory is that group of meta-analysis, which is only those reviews where you can summarize the results in a quantitative way. And this is seen more clearly again in this definition from the Dictionary of Epidemiology, that you can only do meta-analysis if the data is similar enough, if it's comparable. So we tend to think of this as measuring the same thing in the same way. If studies measure different things in the same way, or if they measure the same things in different ways, it produces a challenge to being able to pool the results. So where have systematic reviews come from? Well, the origin of those is nearly as ancient as randomized controlled trials. So in the 18th century, the first randomized controlled trial looked at whether giving people different substances, like, for example, lime juice, helped in the prevention of scurvy. And 6 years after conducting that first randomized controlled trial, the same author, James Lind, who's now commemorated by an electronic library, where you can view, for example, his original work, came up with a critical and chronological view of what has been published on the subject. So the first systematic review was only 6 years after the first randomized controlled trial. And when you see how he describes his activity there, he said that what he was trying to do with this systematic review was to root out prejudices. So think again about that definition about limiting bias. And the idea is to produce a full, so comprehensive, and impartial, so free of bias view of what had previously been published on scurvy. And part of the reason for that was to identify any methodological shortcomings or mistakes, as he called them. And he said that before you can actually look at a subject properly, you need to be able to remove a great deal of rubbish. And this aspiration of removing rubbish is still a major part of doing a systematic review. So what we're seeking to do is gather the research together, get rid of the rubbish, and summarize the best of what remains. And that, in a nutshell, is what you'll be doing in the module with your chosen topic. So some of the milestones, later milestones in systematic reviews, a lot of the early work was done in typhoid. So Carl Pearson did a landmark review in the early 20th century, looking at vaccines against typhoid. And what he did was a form of meta-analysis. He looked at 11 studies to produce average correlations. And then similarly, 3 years later, Joseph Goldberger, again studying typhoid fever, pulled data from 26 of 44 studies that he'd identified. But it wasn't until the mid-1970s that the term meta-analysis was actually coined, and this was devised in the context of social science, not within the context of medicine. But a couple of years later, Ian Chalmers, a leading figure in the evidence-based medicine movement, took evidence on interventions related to pregnancy and childbirth and produced a mammoth project to look at and review the evidence for and against the most common interventions for pregnancy and childbirth. In the mid-1980s, we saw the increase of recognition of the previously unsystematic nature of reviews. So Light and Pillemer produced an authoritative book called Summing Up the Science of Reviewing Research. So if you like, the first book that talked about the value of reviews. Cynthia Mulrow published a condemnation of the existing medical review articles, showing how few of them had used systematic ways of trying to find the evidence and make their conclusion in a systematic way. And then in the early 1990s, an organization was set up called the Cochrane Collaboration, a collaboration of international volunteers with some funding from different governments to review randomized controlled trials and see what pictures could be derived from those. And 7 years later, a similar organization was set up in the areas of social economics and education by a group of followers of Campbell, a leading social scientist. So why are these reviews important? Well, systematic reviews can end confusion where different practitioners are doing different things, each firmly believing that what they're doing is right. Then a systematic review can actually show you the evidence for that. They're also good at taking stock of scientific evidence, so we can see areas where there is not enough evidence or where there is not enough good evidence. They also, by putting the studies together, you can perhaps have the first ever view of a body of evidence and see what the overall pattern is. And we're going to see that in an example that I'll feature shortly on sudden infant death. So increasingly, there's concern about the spending of public monies on research, and so you can actually establish when enough evidence has been produced, you don't need any more randomized controlled trials of a particular subject, and so that you can concentrate on the message from the research that has already been done and channel future research funds at areas that have not been had not seen evidence produced plentifully. And of course, one of the criticisms of using an individual study for decision making is that it may magnify the flaws or errors of that single study, so that you're making a decision based on flawed evidence. And so by looking at the balance or overall picture of studies, then you can resist this. So I'm going to share with you an example that Chalmers used prominently. If you had been a child being brought up in the 1960s with parents in the Western world, then it's highly likely that this book would have been found amongst the bookcases of your parents or their contemporaries. You can see there over 19 million copies of this particular edition were sold. It's a book on how to bring up a child, and this authoritative work made pronouncements not on the basis of evidence on such things as how to put your baby to sleep. And so here we can see the statement, "I think it is preferable to accustom a baby to sleeping on his stomach from the start if he is willing. He may change later when he learns to turn over." And now, of course, we're very aware that this is actually potentially harmful advice. And indeed, in the UK, there have been prominent campaigns to try and stop people putting their baby to sleep on its stomach. Now, this paper was an attempt to summarize the evidence that existed and was accumulated between the years 1940 to 2002, so including the time that that book was published on infant sleeping position. And this historical review found that this advice that had been given could have been shown to have been harmful from at least 1970 onwards. And had this been publicized rather than the paperback book continued to be published, then this could have prevented over 10,000 infant deaths in the UK and at least 50,000 in the other parts of the world that would have been influenced by this book. So for these and other reasons, an epidemiologist named Archie Cochrane, after whom the Cochrane collaboration was named, has said that the medical profession could be criticized for not organizing its evidence in a way that summarized what had been found and allowed it to be updated. And if you look at systematic reviews nowadays, there's a strong movement towards what are called live reviews, where the evidence is incorporated in a review almost as soon as it's published. This is the logo of the Cochrane collaboration. The Cochrane collaboration, as has been mentioned, seeks to gather together evidence, mainly in the form of randomized controlled trials. And this logo actually tells us how systematic reviews and particularly meta-analyses work. So these parallel lines here are different representations of individual studies. And you'll see that when we look at how they are positioned in relation to the central line that goes down the center of the circle, that several of them are overlapping, which shows that the treatment may be potentially beneficial, but on the other hand, where it crosses the line, could equally be harmful. But it's only when pooling these studies together, these 7 individual studies together, that we result in the diamond, which shows a clear pattern in favor of the intervention. This particular intervention was giving corticosteroids to infants that have been born with neonatal distress as a way of saving child lives. And so we can see that whereas if you had followed the individual studies, you would have had a confusing picture, to actually look at the overall pattern of them would allow you to make a definitive and life-saving decision. And these sort of plots, which are called forest plots, are commonly used as a way of representing meta-analyses right up to this day. So here from the BMJ we have an example, and just a few features to look out for here. You have the individual studies and when they were published. You have the comparison between the treatment and the control. And then on the right-hand side here, you have the, in this case, a standard mean difference. So the difference between the achievement in the treatment group and in the control group. You may also see this presented as a ratio. If it's a difference, then of course, if there's no effect, then we see a 0 here. So that line of no effect is a 0. If this was showing a ratio, then that middle line of no effect would be a 1. So if we think of a difference, 50 minus 50 is 0, so our line of no effect is 0. If we think of a ratio, 50 divided by 50 is 1, so our line of no effect would be a 1 there. And you'll see the stylized diamond there. The aeroplane wings, as I describe them, are the confidence intervals, so the range of possible results, a 95% confidence interval. And for the pooled effect, so putting all of these studies together, the diamond, the width of the diamond actually reflects the confidence interval. So for this particular study, you can see individual studies all over the place, but putting them together shows a clear effect in favor of the treatment. Now, just one thing to mention in passing, you'll notice that on this plot, the treatment is favored to the right-hand side. On the Cochrane logo, it was favored to the left-hand side. So it's always very important to see how these plots are oriented, whether a positive outcome is shown on the left or the right-hand side. And we can also see the benefits of accumulating evidence. So here we've got a different form of plot where each new study is added to the result. And what happens is that we see that the result is getting more and more precise, so the confidence intervals are contracting. But this is a sort of horror story, if you like, because what this is showing is that in the textbooks that are being documented in the table on the right-hand side, that they are still recommending treatments for giving this substance lidocaine, even when it had been shown by 15 trials involving 8,745 patients that this treatment was not beneficial. And in fact, it was positively on the harmful side, favoring the control there. And what we see here is this effect that the more patients that you put in to the meta-analysis, the tighter the confidence interval, so the more certainty we have around the result. So hopefully you can see some of the benefits of using systematic reviews. And so it's not surprising that systematic reviews have grown in their popularity. These are two different ways of representing that. And that makes it opportune for us to be able to recognize a systematic review when we see one. So how would we do that? Well, we'd be able to identify a systematic review as opposed to an ordinary review by its clear objectives, by it having comprehensive search strategies, so an attempt to find unpublished as well as published studies, by very clear criteria on whether whether studies are to be included or excluded. So particular populations, particular age groups, particular dosages, these could be specified as part of the review. We also see that each individual study is clearly presented, often in the form of tables or diagrams, as we've seen in some of the examples before, that each study that goes into the review is assessed for its methodological quality, and this is done using a checklist, which will be shown later, that there's a clear analysis of the results, and that finally the review is reported in a very structured and easy to navigate way. So once you know how to read a systematic review, then you can read other systematic reviews. Navigating around a Cochrane review will allow you to navigate around other Cochrane reviews because of the standard format for reporting. So to conclude, what are the stages of a systematic review? Well, they fall into three stages. There's the planning of the review, which is signaled by the development of a review protocol, and this involves identifying a need for a review and preparing the proposal. Conducting the review, which is about finding the studies, selecting the studies, assessing them for quality and synthesizing the data, and then reporting and disseminating the review with a view to getting the evidence into practice. Now, it's true that systematic reviews have been criticized, and you can criticize this slide even more because it seems to have been produced very strangely, so apologies for the lack of clarity. The master slide should be clearer when you download it. But we can see some of the criticisms here. They've been criticized because people can put together apples and oranges. So in other words, studies that aren't meant to be put together. So for example, people might put together psychological studies with drug studies, and these work in quite different ways. So is it a valid comparison to look at these two different types of studies with different mechanisms? We can see that there are criticisms in terms of the thinness of detail. So if you take a study report, you're actually stripping out a lot of the detail, throwing a lot of the context away in order to analyze the results. And so the criticism has been made that in the wrong hands, a tool has become a weapon. But we have to pause here and say that these aren't actually criticisms of systematic reviews per se. They're really criticisms of doing systematic reviews badly. This criticism of apples and oranges, it's very tempting when you're looking at a topic to try and include any study that's potentially relevant. But of course, that means that the studies can be very different from each other, and the differences could be more important than the similarities. So there's this lovely quotation here saying it's bad enough to mix apples and oranges together, but if you throw in sprouts, turnips, and an old sock, then that means that any statistical estimate can immediately be challenged. Another criticism we've already said is this idea that when you take the data out of a randomized controlled trial, you're stripping away everything except the bare bones of the study. So you're losing a lot of the context, which is what the practitioners and policymakers need to know. So why a systematic review is not universally popular? Well, again, it's when they're done badly or they're not done in a helpful way. Systematic reviews that focus on their methodology aren't that helpful for clinicians who want to make a decision. Systematic reviews are only as good as the studies that they include, so they may find only poor quality studies. To make the review easier, people might focus on a narrow, non-representative clinical population, so a population that's easier to study. If you think of how randomized controlled trials tend to focus on young white males as their populations, but they do this to test drugs that are going to be used on people of different genders, of different ethnic backgrounds, different age groups. Systematic reviews might choose outcome measures that are easy to measure but are not relevant for a clinician. Or they might look at short-term outcomes when a clinician is interested in the long-term outcome. Or they might use measurement tools that clinicians don't find useful in practice. The systematic reviews may wrongly use meta-analysis, and above all, they may just trot out that more research is needed, so they don't actually help to reduce uncertainty. So, in summary then, we've seen that systematic reviews of reliable, relevant research should be used. Although we focused very much on the effectiveness, they can be also used for qualitative purposes, like looking at feasibility, acceptability, and meaningfulness of interventions. And many of you may well choose a qualitative option for your assignment. They can be used to plan further research, and they can be also used to set new results in context. So I have several examples from my own qualitative systematic review experience, where by putting studies together, you've been able to see a unique new picture or new vision that wasn't previously seen in individual studies. But on the other side, systematic reviews are said to be only as good as the studies that make up the review. They are, after all, even though they use randomized controlled trials, the review method itself is a form of observation, albeit often by two observers rather than a single observer. And they have been criticized with memorable terms like being called an exercise in meta-silliness or statistical alchemy, so turning lead into gold for the 21st century. So just to point you at a couple of useful sources, we've tended to focus in this lecture on the conventional systematic review, but there are many other types of review that you can see reviewed in our recent article that you can obtain through the library collection. In terms of where do you start for finding your way around this, then there's a free online guide produced by the Centre for Reviews and Dissemination, and a very good thin volume, ideal if you're going on to do this for a dissertation, is the book by Aviard, which follows the same structure as the Centre for Reviews and Dissemination guidance. Here are some of the references to the research that I highlighted earlier, and again we have another useful book that you may want to borrow from the library by Goff and colleagues. So thank you for your attention, and we'd now like you to check your understanding using the online quiz that we will point you to.